Okay, here we are on number 21. We're going to finish this one up. I've got this polynomial, and the question is, what do I add to this polynomial to get to this binomial here? And you could do a variety of methods to try to figure this out. One is to say, the one that I'm going to do is I'm going to say this big one here minus this one is the smaller one, or the lesser one, because I'm adding something to this one to get to this one. So I could take this one, 4x squared minus 3, and I subtract x squared plus 5x plus 1, and what I'm going to get is what would I add to this one to get to this one. Like if I was to say, what do I add to 3 to get to 5? I could do this kind of backwards and say, what's 5 minus 3? That gives me 2. 2 is what I would add to 3 to get to 5. I'm just doing that same thing here, except for I've got all of these, letters in here. So here we go. 4x squared minus 3 minus x squared, this negative needs to be distributed, minus 5x minus 1. And now I have to combine like terms, which is the same variable raised to the same power. 4x squared minus x, that gives me 3x squared. I've taken care of those. And now I have a 3 and a negative 1, and I only have one of these x's here. So I have minus 5x, maybe make that minus a little bit better. I've taken care of the x, and then I have negative 3 minus 1, negative 4. And that is number, yeah, there we go. Number 21. That's where we're at. Yep. So if I were to add this to this, I would get this. That's what they're asking for. Number 22. Okay, number 22, find the least common multiple. All right, I've got 21, 33, and 13. Now, this is going to get to a really big number. The way that I would do this is I'd take this biggest number here, the greatest number, and I just multiply this by its, I would add it to itself over and over again here. So I've got 66, 21 doesn't go into 66, 13 doesn't go into 66, I don't know, it doesn't really matter. They all have to go into the same number. And you're going to end up going really far here. 33 times 13, let's see what that is. Oh, that's only 429. All right. You're going to take a while. Now, there is probably some method to do this and you factor everything out. And then you end up with what you need to multiply together. That's the way to do it, but I don't remember how to do that. So anyway, you're going to end up with 3003. Mrs. Voorhees might not like how I did that one, but that's how there he is. Alright, number 23. Same thing. We're going to find the least common multiple of 8, 32, and 12. This one's going to work a little bit more like how I did this, was going to do this one up here. 32 times 32 is 64. 8 goes into 64, but 12 does not. I'm going to add another 32 to this, and that gives me 96. 8 goes into 96, and 12 also goes into 96. If I divide 96 by 12, I get 8. So 96 is your least common multiple for number 23. Number 26, here we go. The area of a circle is 20 pi centimeters squared. So my area of the circle is 20 pi centimeters squared. How long is its radius? So I need to find out what is my radius. That's what I'm doing for A. Let's see what B is going to be asking me here for number 26. B, use the expression to find the length oh, it's asking me first write an expression that can be used to find the length of the radius of the circle, given the area. Use the expression to find the length of the radius. Alright, so it asks us a question and then it split it up into two pieces. So first what we're going to do is we're going to write an equation that gives us the radius in terms of area. So before we worry about this 20 pi centimeters squared, let's write the area of a circle. The area of a circle is pi r squared. Now what they're asking you to do here is solve for the radius. That's what they're asking in A. Write the expression that can be used to find the length of the radius of a circle. What they're saying here, what they're asking for is solve for the radius. So what we're going to do here is we're going to divide both sides by pi in order to get the pi out of there. And then I'm going to flip this so it's r squared equals area over pi. And then we want r to not be squared, so we're going to take the square root of both sides. That gives me the square root of r squared is r. So r equals the square root of the area over pi. So here's what they're asking for A. For B, they're asking you to find out what is the radius there. So what we're going to do here is we're going to take our equation that we just found and we plug in our area, 20 pi, over pi. So I've just taken my area, substituted 20 pi for my area, and put that over pi, and I'm going to take the square root of all of that mess to find my area, for my radius. Pi divided by pi is 1. The radius then equals the square root of 20. Now, they didn't say if they want this. We'll keep it in terms of radical. We won't put it in the calculator. So 20 is 5 times 4, and 4 is 2 times 2. There again it is my 2 times 2, which is going to come out of the radical, and my 5 is going to have to stay. My radius is 5 times the square root of 2 centimeters squared. So that's B there. And we still have one more to do, number 28. Translate each inequality into a sentence. 28, I've got 3g minus 4 is less than negative 2. In the book, the sample answer is the product of an unknown and 3 minus 4 is less than negative 2. And that's a perfectly fine way to say that. You might also say the product of 3 and a number. It says unknown here in the book, and that might be the terminology that you guys are using. So the product of 3 and an unknown minus 4 is less than negative 2. You might put 3 times a number minus 4 is less than negative 2. It depends on, that would probably be acceptable as well. That is your homework, lesson 61.